Hi everyone, welcome to another maths video by Maths with Sarah. Today we're going to be looking at this rather tricky probability question from the paper from November 2018. It is a paper 2, so you are allowed to use a calculator. It's a higher paper and it's question 16, so it's most definitely at the back of the paper, which is why it's particularly tricky. And because this is a probability question, there's quite a lot going on. There's a lot of text, a lot that needs to be read through. And also we need to understand exactly what's going on, because obviously that's going to have a bearing on how we tackle this question. So we've got red and blue counters only in a bag, and Joe takes a counter at random. The probability that the counter is red is 0.65. So hopefully at this point we're thinking, right, the probability that the counter is blue is basically everything else. So it's remember, probabilities are going to add up to make 1. So the probability that the counter is blue is going to be 0.35. So we've already kind of worked out one bit. This would get you 1 mark to work, just working out what the probability that the counter is blue. And we can obviously work out that step fairly easily. So Joe then puts the counter back into the bag. Okay, so this is very important at this point. We're replacing the counter. We don't have to worry about the fact that we've removed one and then what's the fact that we've removed one counter and one collar. We're putting the counter back in the bag. Mary then takes a counter at random from the bag and she puts it back in the bag as well. Okay, so we then want to know what is the probability that Joe and Mary take counters of different colours. So for example, the first counter being red and the second one being blue, or the opposite way round, the first counter being blue and the second one being red. So I reckon we definitely need a bit of colour on this one. It's going to make it a lot easier to understand. And hopefully at this point you're all thinking, right, we definitely need a tree diagram. It's always the best way to tackle a probability question. So we have got the probability of the first counter being red is 0.65. We just said that we've all just worked out the probability of the counter being blue is 0.35. Okay. Now this is the important bit. The counter is then put back into the bag. So we don't have to worry about the probabilities changing. They're going to stay exactly the same. So the probability of the second counter being pulled out and being red or blue is going to be exactly the same probability that it was in the first place. So the probability of the second counter, of Mary's counter being red, is going to be 0.65, regardless of what has gone on before. Like they're completely separate probabilities. And obviously the same for the blue one. The probability that the counter is blue does not change. It still stays the same as being 0.35. Okay, so now we've got a tree diagram. We know we've got red, 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 blue, blue, red, and blue, blue. So now we need to look at what the question's actually asking us. So the question is saying, what is the probability that Joe and Mary, so we've got Joe first, then Mary, take counters of different colours? Okay, so if we look at which branches of the tree diagram we're going down, we can ignore most of them. We want the first one, which is red and then blue. That's an important one. We then also want blue and then red. That's another one that's important. This one here, we don't care about. This one here, we don't care about, because that will be the probability that they get the same colour. Okay. So to work out the probability that they take first a red counter and then a blue counter, we're going to do 0.65 times by 0.35. And that is going to give us 0.2275. And then obviously the probability for this one will be 0.35 times 0.65, which obviously is exactly the same as the first one. It's just that we put the decimals in a different order. Obviously for timesing, that doesn't make any, or multiplying, that doesn't make any difference whatsoever. So again, the probability of getting blue then red is exactly the same. It's still going to be 0.2275. This is a 7 here. Okay, so the next step is we need to work out what the total probability. What is the total probability? So we've obviously done the probability for red then blue, and we've done the probability for blue then red. We want to work out, if we combine these two together, what is the overall probability for taking counters of different colours. So all we need to do is just add these two together. And if we add them together, we get the probability as being 0.455. Okay. And that is our probability. That is all we need to do for for that first part of the question. We're going to just draw our 2 diagram, multiply down the branches that we need, so ignoring the 2 that don't apply for this scenario, add those probabilities together, and we end up with our answer. Actually relatively straightforward compared to what it initially looked like. But there is a second part to this question as well. And this second part, again, is a little bit tricky. So we've been told there are 78 red counters in the bag, and we need to work out how many blue counters there are. So we have got, and again, before I start doing this, there are multiple ways of working this one out. I appreciate that some people will find one method easier than others, but this, just for now, I'm just rubbing a little bit out so that I've got plenty of space to do the working out. Again, yeah, there are multiple ways of working this out. If you want to do it a different way, or you know, you don't necessarily fully understand the method that I've used, I am going to be doing 2 different methods. So hopefully, if one doesn't necessarily make full sense, then the other one will be fine. So we have been told we have got 78 counters, and this is in the red category. Now, the probability of the counter being red is 0.65. Now, some of you might be absolutely fine using doing all the maths when it's a decimal. For me, I'm not a massive fan of decimals. I'd rather turn it into a percentage. So I'm going to say that this is equivalent to 65%. Now, obviously, hopefully you're perfectly happy with converting from a decimal into a percentage. We're then going to look at the blue counters. Now, obviously, we don't know how many counters are blue. We don't even know how many counters are in the bag, so we can't work out how many counters are blue directly. But we do know 2 other facts, or 2 other parts of this. We know that the probability that the counter is blue is either 0.35 or 35%. Okay. So what I'm going to do now is I want to work out, I'm going to use this red side. Obviously, for now, that's all that really matters. That's all the one that we've got information about. So I know that 65% is equal to 78 counters. I don't want to know what 65% is, though, do I? I want to work out what 35% is. The easiest way of me doing this, again, see multiple different ways of doing this, I'm just going to immediately divide by 65 to work out what 1% is, and then I can multiply up to work out what 35% is. If I do this, I work out that 1% is 1.2 counters, which obviously isn't actually applicable. It's not possible, but just for a mid step in this working out, it's fine. And then I can times it by 35%, which is the percentage that I want to find out to work out the number of blue counters. So this is going to give me my 35%. And if I do that, I do 1.2. I'll also do the same on this side, so I divide that in earlier. So we divide by 65 and then multiply by 35. And if I do 1.2 times by 35, then I end up with 42 blue counters. I said there was another way of doing it. The alternative method is that we say, I've got here where I've got a little bit more space. So this is exactly the same question, just a different version of it. We can say that we've got 0.65 is equal to 78. Now I want to work out what 0.35 is. Again, I can go via 1. So I can start by dividing by 0.65 to turn from 0.65 into just 1. So do the same on the other side. So divide by 0.65. If I do this, then I end up with 120. And this 120 is the equivalent of all of the counters in the packet or in the bag. So what we could do now is just work out what we need to add to 78 to make 120. Alternatively, we could continue with this and we could say, well, actually, that's just times by 0.35. That works just as well. Multiply by 0.35 and not surprisingly, we end up with 42. Again, obviously 2 different methods, both the same answer, exactly what we want. So that's that question. We've been asked how many blue counters there are in the bag. And we know we've worked out from 2 different methods that we've got 42 counters in the bag. Again, there will be other methods of doing this. If this doesn't work for you, obviously I've just done it using the percentage. It's the same method, it's just either using percentage or decimal. There are many other ways of doing this. So again, if you found a different way then and you get 42, then that's absolutely fine. Okay, hopefully that video was helpful for you. I would appreciate if you could like and subscribe to the channel, just so that I can work out how many people are viewing these videos. Thank you very much for watching.